Well, here today, my name is Brian Wilson. I'm the president of Duro UAS, which roughly translates into Tough Unmanned Autonomous Systems. We are a young startup that manufactures robotics, mostly autonomous vehicles, land, sea, and air for environmental mapping and data collection, and civil infrastructure mapping and data collection. Actually, you see here, we're in the process of building our first AUV, autonomous underwater vehicle, that will be used for two projects here in the New York City area. One is for the Billion Oyster Project, which is currently happening in the port of New York, New Jersey, the Hudson River, Gowanus Canal area. Have anybody been to Governor's Island here? I know what Governor's Island is. So, yeah, Governor's Island is where the New York Harbor School is based, and also the Billion Oyster Project. So we'll be using this vehicle to collect water quality data in key areas where we're looking to plant these artificial reefs, as well as doing mapping of the areas to find optimal areas to plant these reefs. They have about, I think, 3 to 4 million oysters planted so far, so they have a long ways to go. We're also going to be using this vehicle for a project coming up towards the end of the year with the Region 2 Transportation Center to assess bridge scour. Do you know what bridge scour is, anybody? So the number one problem or issue with bridges and failure of bridges, not only here in the United States but worldwide, is something called bridge scour. And basically when you put bridges and you build them, you put the pylons into the sediment, they dump rocks and debris over it, and just naturally over time the currents wash that away, and when that happens, structural integrity fails and bridges collapse. It has been the reason for over, once again, 55% of bridge collapses in the history of bridges being built is because of scour. Traditional ways of doing inspections for that is tedious, cumbersome, and not accurate. They send divers down poking sticks in the mud. Is it soft? Is it not? They try to bury little transponders and PVC pipes and stuff into the sediment, hoping that if it starts to erode, it'll pop up and they'll know that it's time to check it. Not really great ways to go. So our focus is, once again, civil infrastructure and environmental, but for urban environments. Today, robotics and the use of autonomous vehicles as a whole is growing. One, because they are much more effective at getting into dangerous areas and collecting data. So that makes them obviously more cost-effective and safer tool. Plus, you can inspect and be much more accurate with what you're using these for. Unfortunately, as humans, being responsible for inspecting stuff, we are not very vigilant. We cannot focus on one thing for a very long period of time. Thus, most of the catastrophes that you see happening, including here in New York City, which you can see a picture of one here that we took from about 2 years ago, which was the gas explosion in Harlem, can be prevented. That happened because when people called Con Edison to report the smell of gas, the guy didn't have enough time to get there, because by the time they called him, he put down his cigarette, got in his truck, drove off to the area to get out his sensor. The buildings exploded and 9 people died. So a big push for me in starting Duro, just so you guys know, is it's time to stop living in a reactive society. Technology is here, and live in a proactive or a preventive society. A lot of the things that you've seen happen here in the city, from cranes collapsing, Amtrak trains flying off the tracks, gas explosions, tens of millions of dollars of damage from pipes bursting, can be solved and prevented. Unfortunately, we don't live in a world where people care much about that. They'd rather wait for people to die and then say, well, now we'll fix it. So we have a big push in changing that mentality. We can improve the lives of everybody in these cities, make them more sustainable and much safer using sensors and autonomous vehicles. We do a variety of things also outside of manufacturing, just so you all know too. We do a wide variety of STEM-related workshops and programs with middle schools, high schools, and an apprenticeship program with university students. Here you can see some pictures of a test recently we did with our transducers actually in the Governor's Island area. We're going to be using sonars to do some depth readings to see where the sediment is harder and softer for the bridge scour analysis. We could also inspect pylons or any kind of structures for the bridges. We also work with different agencies. We partnered up with NOAA CREST, which NOAA is the National Oceanic Atmospheric Administration, to gather a lot of environmental data in this area. Now, the AUV that we're building now, and I really love seeing a lot of the projects you guys are building here, the vehicle that we're currently building will be a fully autonomous vehicle. which means that it will operate on its own. It will have some very low-level artificial intelligence and machine learning in it. It's going to be about 6.5 feet in length, weigh around 110 pounds, mostly made of aluminum and polycarbonate materials. We're expecting to get about 4 to 6 hours out of the vehicle based on the battery configuration we have now. And as far as sensors, just to give you an idea, because I saw a few of you working with a variety of sensors, we will be using sound, obviously transducers for avoidance, for mapping. We have compasses, GPS, inertial navigation unit, gyroscopes, accelerometers, a Doppler velocity logger, which is used to track the speed of something in the water over the ground, and using all those to calculate the navigation for the vehicle. And then we'll have different sensors for the water that collect stuff as salinity, oxygenation, turbidity, to paint a clearer picture of the actual quality of the water in the area. This is just a little video here to give you an idea. Now we'll skip over that. These are just some shots of our space. We have 3 locations. We have main administrative offices in the South Bronx. We manufacture currently on the campus of City College, where we have space in the cellar. And we also have space at the Harlem Collective, which is near City College, where we do our youth programming and our marketing out of. And this is just a variety of the engineers working on different projects. That's actually the battery pressure vessel that we finished about a month ago. We fabricate as much as we can from scratch, just like all of you here. So we buy blocks of aluminum, we put them into mills and lathes, and we fabricate everything from ourselves. The only things we're not making at this time are the cameras, the thrusters, and a few other sensors. We're going to buy them off the shelf. And just a few more sonar images, some images of the pressure vessel. We have a big area with massive buckets filled with water where we do our thruster testing. And you can, of course, check us out at DuroUAS.com. We have a blog and things along those lines. As far as me, they were saying that you guys like to kind of know maybe how businesses got started, so I'll tell you a little bit of my background. I actually started out in the fashion industry, very different from robotics, where I was a scout. My job was to walk around Manhattan and look for good-looking people. But it wasn't very rewarding. Originally, by nature, I was always a tinkerer and kind of a self-taught engineer. I went to college initially, back in the 80s, for computer engineering. But at that time, computers and programming was not that attractive once I got into it. It was just like sitting in a cubicle, no windows, working with big floppy disks. So I kind of veered from that and got into entrepreneurship. After I worked in the fashion industry, I started to work for a school here in Manhattan called the 3D Training Institute, where I would help kids and adults learn 3D animation using software such as 3ds Max, Maya, and Revit. Mostly teaching people how to get into the movie industry, gaming industry, commercials, and architecture. Through that, I was able to develop and train the school from a traditional in-classroom like this to a completely live online format. So I've always been interested in automating things and alleviating the waste of time that a lot of us use in doing trivial tasks that should be automated or streamlined in a better way. About 2.5, 3 years ago, after that Harlem gas explosion incident, was what spawned me and my partner Gabriel Foreman to start Duro UAS. I was already a tinker myself. I had a variety of quadcopters. I was always experimenting, building with them, flying throughout the city, and I started to understand the need and the use of these vehicles today and now, and not 15 to 20 years in the future. We eventually started to team up with some local organizations in the area, including, once again, the New York Harbor School. And that's when I realized, because originally I was going to go in the aerial market, which we still are going to do air, but then I saw that there was a big need for vehicles for underwater. Oyster restoration in the United States is a big push, because oysters form natural barriers that help against storm surges. They actually lessen wave energy, and they clean the water at an amazing rate. So across the country, they're really starting to figure out ways to reintroduce oysters along the coastlines to protect against the hurricanes and the other natural events that we're going to always run into and occur. So for me, it was a market opportunity and a need as well for us to better understand our oceans and the blue economy. So any questions for me about anything?
How would you help to prevent hurricanes, or at least get a fair warning about them?
Well, these wouldn't really be used for that, but as far as an analysis of the water and the coastal areaways to plant oysters, and then there's another project that they're doing here in Manhattan called Rebuild by Design. So when Sandy came through this area, it flooded the lower part of Manhattan, and then it also flooded the lower part of the South Bronx. And the interesting thing about that hurricane was that in the lower part of Manhattan, obviously you have trillions of dollars of assets, tons of servers for Wall Street. So it was a big wake-up call for the city and for the state. Because if that floods out, you know, yeah, things are backed up now for NASDAQs and stuff, but you would have a massive amount of damage. It would affect not only New York City, but it's a global catastrophe. The second area in the Hunts Point area of the South Bronx is the second largest food distribution center here in the United States, and I think it's the third in the world. That food distribution center at Hunts Point, which people usually don't go there because it's maybe not the best of areas, feeds over 60% of the tri-state area. So if that would have gotten flooded, all of us here would have instantly started to see a big issue with food in the area. We'd be eating out of cans until they could have got that fixed there. So they're really key infrastructure parts for the country and for this area. So they have a project called Rebuild by Design where they're trying to build part natural and artificial barriers along those areas. Now, if any of you have been down to Governor's Island and you look back at Manhattan, it's a beautiful skyline. The trouble of creating these artificial structures is you can't just put big walls up because then people are going to complain that you've ruined the skyline of New York City. So it's a balance of, well, we have to appease people on how it's going to look, but we also need to be serious about protecting the island from flooding and from storm surges. So this would be used for mapping for that, but not necessarily for anything related to storm events and predicting that.
How many people are on your team?
We have overall, including engineers, marketing, and everything, about 30 people.
What can you do about bridge scarring once you detect it?
So the big key is that once you're able to detect it, you're able to put on the priority list what bridges need to be assessed first. You know, one of the things, once again, that really makes me passionate about what I'm doing and why I like to talk to you about it, because you live here in the city, you travel into the city. Last year, in January, the Canal Corporation of New York State, which is responsible for inspecting bridges and tunnel, comes out with their yearly report. And the first two paragraphs of the report states that there is currently, right now, 12 structures throughout the city that are flagged as critical, that at any point in time, they are going to have some kind of a catastrophic failure, and they're supposed to be inspected every 2 years. That not only have they not inspected them in the past 2 years, but they do not know when and if they will be able to get to it. So this is going to allow them to set priorities, because the way things are inspected now, they have a big list. Okay, so this year let's inspect these two. Yeah, this is kind of old, we should inspect this. Yeah, let's do this one. There's no reason in rhyme. There should be a reason in rhyme. If these are marked critical, go inspect those and get them fixed. Why are you looking at something else? So it's a very much, once again, a preventive way to tell them. Another issue too is inspecting bridge towers is important during and after storm events. So right now, they usually go out and inspect these during ebb tide, clear skies, less turbidity in the water, when it's safer for divers to go in. It's not a great time to go down and get those accurate readings. So these vehicles can be put in the water during a storm event when you're going to see the heaviest flow of the water and see what's actually happening, and directly after that. So they'll be able to assess things in a much better way.
You mentioned helping school kids, or allowing school kids to help you, or you mentoring school kids. How would a high school kid get involved with you at UAS?
I'll share my information before we go, but if you go to the website, there's like an inquiry form. You can just submit through there. We have what we call our junior team. We have about 4 people on that now, and that's where we bring them in. They come in and we get to teach and enhance what their interest is. So if it's computers, maybe more programming, working with microcontrollers. If it's electrical, breadboarding, understanding how to test power things. If it's mechanical, learning how to use SolidWorks and design. So we really do have, you know, it's about hands-on. And that's one of the things I love about here. I work with a lot of university students, and even though a lot of kids go to some great schools and they graduate, I can sit some of them down and be like, hey, can you solder this together for me? And they'll be like, like, you don't have solder. You know, you got your PhD, what's going on here? Well, you know, it's just theory. Everything's computer and theory. So getting hands-on is I'm passionate about. I'm actually trying to create an apprenticeship program. I just met with the state on Monday for funding for machines and for a facility to do real actual apprenticeship training on manufacturing. So how to use lathes, mills, weld, how to physically bring things to life, because there's a big lack of that currently, and there's a big need for it. So I'll give you my information here, and you could
Okay.
send it.
What are some of the main materials that you use in your products?
So for this, it's mostly 6061 aluminum and then polycarbonate plastics. Though the shell of the vehicle itself will make initially out of fiberglass, but then eventually we'll probably use carbon fiber or a mix material like a composite, something that's a little bit more hydrophobic to help us with the kind of the hydrodynamics of the vehicle.
Can you talk a little bit more about the machine learning and AI that goes on during a mission?
Yeah, so one of the hardest things with underwater is navigation. You have to realize there's no GPS signal, there's no Wi-Fi, unless you have a transponder floating in the water communicating, you're using what's called ultra long baseline or dead reckoning navigation techniques. So what happens is you have to really train the machine to understand where it's at after you've created a map, and then use that for it to learn the environment. So for the navigation, there's going to be some machine learning where we'll get a sonar map of an area. Then when we put the vehicle in the second time, it's going to be reading that map, but any anomalies that are different, it will detect and will react based on that. And what I call that is curious. So all our vehicles, our water, our land, and our sea vehicles, we're going to be programming them to be what's called curious vehicles. So if it's used to going through an area and it knows there's an oyster bed, there's an oyster bed, and then all of a sudden it notices there's a big block of something over here that's never been there before, that it literally would break its mission, say, hold on a second, I've never seen this in my data thread, investigate, turn the cameras on, the sensors, hover for a minute, and then get back on your mission. We'll also be using it for object recognition as well, so the cameras will be used, even in urban water, there's algorithms to improve and get some basic shapes from a murky object. So we'll train this to look for oyster beds, so that once again it can automatically detect them and know where they're at without us having to look through cameras and stuff. And then also we're looking to use it for the bridge scour assessment. For us to accurately do bridge scour assessment, you want to place the vehicle in the same position each time you go there so that you can compare the images. So we're thinking about actually using the vehicle. We could actually tag a marker on the pylons, on the cement underneath the water, and then use that as a image recognition system to constantly line up exactly where it's at. And we'll also put some very basic sniffer capabilities in the vehicle eventually as well, where let's say that we're looking for a very specific pollutant in the water and we want to see where the source is, that the vehicle is literally just kind of following the concentration of that to the area where those pollutants are being dumped into the river.
Aside from the machines you talked about, are there any other machines that you're planning on making or are currently making?
Our focus right now is with this AUV. Once we're done with this, then we will move into the commercial version. And like any prototypes, it'll get smaller, lighter, a little bit more robust. And then in the first quarter of next year, we'll start moving forward with the initial prototype for our first aerial vehicle. Then we'll go into a smaller version of this for pipes, and then eventually a deep sea. So all of our vehicle lines, we have 3 versions. We have the shallow water AUV, we have a pipe version, and then we have a deep sea version. For the aerial vehicles, they're more built custom for the client. So for first responders, there's a aerial vehicle that's meant specifically first responders. So those would have things on there such as infrared cameras, obviously lights, sensors that are going to help them assess a disaster area in a faster way. There's going to be other ones used for environmental, in which case there'd be different sensors on there. Or for mapping, we would use LiDARs to map the streets. They're trying to build the next airway for the future for drones. The FAA has their next generation airspace regulations. And part of that is figuring out how can you have drones operate safely, not only in an urban environment, but just in general. So my goal is to start mapping the city out using LiDARs to start to build that foundation or that roadmap for vehicles to be able to fly autonomously and safely in the city.
Have any foreign governments taken interest in what you're doing?
I do get solicited by everybody, including, of course, the military from the United States, but we're not building weaponized vehicles. And as we do get these out into the market, obviously for mapping and for data collection, if they want to purchase them, I probably would not say no. But and we're looking to really just focus on the United States for now. I'm not going to sell these vehicles outside the United States, at least until the next 4 to 5 years. And for that, it's more so of a technology standpoint, because once something gets out of your hands, it's going to be reverse engineered, and then they're going to be replicating it there. So we are putting in patents for this. This is not the real vehicle. The other picture was close. We don't release the real pictures because we have certain mechanical designs and things that we're patenting. So initially it'd be mostly for the United States, and then eventually Canada, South America, and abroad.
You seem to be working like at a very fast time schedule. Does like the government is not known for being super efficient and speedy, so does that ever conflict with yours?
No, because for Duro and for me, I'm taking a very much a different approach. Like for this vehicle here, as we collect data in the harbor, we're sharing that with the public. A lot of data is collected in general about our environments that none of you know about because they don't release to the public because they don't want you to know. They don't want you to know there's lead in the water. They don't want you to know that there's pollution in the air. You have to dig for it, and then you can get it and be like, oh, now I know. So by being very proactive in that, it's going to help accelerate and put pressure on state, federal authorities to say, you know what, we need to start using these tools now because look what they're showing the issues. And trust me, they want to be preventative as well. More so for me, it would be getting paid from them would be a slow process. But as far as them integrating these, they already have an interest and they want these tools. We're even applying for some grants through them for projects related to this. One of them we're doing now with 4 schools, and it's for a MOFERS grant. Morphing, I forget the exact terms for it, but it's a 10-year project with Rensselaer Polytechnical Institute, Princeton, City Colleges of New York, the University of Michigan. It's to develop vehicles, specifically water, aerial, and buildings that morph and change shapes based on the needs and the environment that they're in. So think of like transformers. So, for example, for this, if we're on the surface, we would use different types of materials or electrical heliological fluids or piezoelectric materials that we're on the surface. The front of it's like a boat and it's sharp. We want to cut through the water. But as soon as it submerges, it automatically gets into an optimal shape to be hydrodynamic. So we're going to be collaborating with them on that. And it's a natural evolution of robotics in general, is the ability for these vehicles to adapt to their environment and work in them the best way they can, on their own. Not a human telling that vehicle can use its sensors and use the data and process that much faster than a person trying to say, oh, well, maybe we need to switch to this. Any other questions?